Hey guys, in this video we're going to describe the difference between a serializable isolation level and non-repeatable isolation level. I've searched the web and there are very little resources talking about this. So I wanted to make a video to talk about the difference between them and then why would you pick serializable isolation level over non-repeatable. Let's jump into it, guys. So here's an example where you have a read committed or a non-repeatable isolation level. Okay, so let's say we have a table, we have AA here as values and BB here. Okay, so you assume this is a table of field and these are just four values, four rows with these kind of values. Transaction number one changes A's to B's. Transaction number two, the green one, changes B's to A's. So it's literally update table set field equal B where field equal A. And the other one is the reverse. So what happens if they execute concurrently? So both of them start at the same time, and then this transaction starts. Obviously, it changes all the A's to B's, and so it's only going to touch these two rows, so it's going to become BB. However, the second transaction, its view, current view is it's reading AABB, and it's going to query and find that these are the two B's, and it's going to change them to A. So technically, this transaction changed only these two rows. This transaction changed only these two rows. So they did not step on each other's toe. So there is technically no concurrency issue if you thought about it, right? So non-repeatable read will not catch anything. Says, hey, you guys didn't step on each other's toes. Like nobody edited anything, edited the same value on different transactions. So that's fine when it comes to read committed and run repeatable. But that leads to a result that is as like this, BB and AA. It's like almost flipped. Maybe this is what exactly you want. But sometimes this is not what you want as a user in this current domain, right? This is what you want. You want the transactions to be actually serialized. No, I want No, if there is dependency when it comes to reading and writing, and that can change the result, I need you to be serialized, as if like each transaction are physically executed after each other, almost physically executed. The databases don't implement it this way, but this is how serializable look like at least. So in this case, when we start with T1, we change all the A's to B's, and then, okay, we only touch these B's, right? So that will obviously, transaction number one only touch this row. But now when T2 starts, it has a different view of the database. It has a different state. So when it looks at that, oh, all of these guys are B's. So I'm going to read all of them, right? So it started with a different version, if you will. And now all of them will be A's. And based on where you start, if it's transaction 2 starts, you're going to end up with B's, right? So that's what we're going to explain. Let's jump into the actual Postgres terminal and explain this stuff. So here, guys, I have my beautiful table that is called test. And this is the BBAA. That's what I have today, right? So what I want to do here, I'm going to begin a transaction that is, let's say, a non-repeatable read transaction. So I show you the problem first, right? And let's do it. Begin transaction, isolation level, non-repeatable read. Let's confuse those two. And then do the same thing here. Begin transaction, isolation level, repeatable read. Both of them are repeatable read. So those guys, this guy says, okay, update test set T, the field, equal A, where T equal B. And then we're going to copy the exact same statement, so we don't have to type it all the time. And then go to the other one, and then change B's to A's here. If I do that, obviously we're on a non-repeatable read. So if I do select star from test, I get all A's. If I do select star from test, I get all B's because I'm isolated. But now, let's say I commit here, and then I commit here, and then I do select star from A, test. Look what we get. We get select AABB, select star from test. We get the same state essentially because the rows that changed didn't overlap. But this is not what we want, as we showed. I want these puppies to be serialized so I can get all A's or all B's. That's what I want. So let's start a transaction that is called isolation level serializable. Serializable. Can't spell this thing, man. All right. Begin transaction isolation level serializable. All right. So now we're in a serializable manner, right? So now if I query, all right, my table is AABB, right? So it's almost the same state. So now I'm gonna do boop boop. Hopefully it's still there, the query. Nice. I'm gonna change all my A's to B's. Boom. And now I'm gonna change all my B's to A's here. And now I'm gonna commit. Look what will happen. Committing here says, okay, that's fine. I commit you guys. You get all B's. But now the other party will want to commit is, hey, this is my one to change. But look at that. Postgres says, nope, babe, nope. Could not serialize access due to read-write dependencies among transactions. Reason code, cancelled on identification as a pivot during commit attempt. The transaction might succeed if retry. That is the case when you do an unrepeatable and serializable. You have to be prepared as an engineer, a database engineer or developer, to retry the transaction in case of these failures. Because what Postgres did is doing more work, is actually looking for dependencies. And it's doing some magic here. That's like, okay, you're writing something that this guy is reading, and you're writing something that this guy is reading. I cannot let you commit this stuff. And since you are in a serializable isolation level, to guarantee that serializability, sorry, I cannot let you commit. Fail, do it again. So this transaction now has been rolled back. And then as a result, I get this state in this case, which is almost what we want to do. So now if I executed this again, right? Let's go ahead and do begin transaction, boom, and I do boom, and I do commit. It's not going to yell at me because no other transaction are in transit, let's say. So if I do that, we get all A's. And that's exactly how serializable works. If you want to do serializability, prepare to get failures, right? There are other ways to achieve this by doing pessimistically obtain lock. Right? Say, hey, this puppy is mine now. I'm gonna obtain select for update, whatever, right? So hey, don't touch this stuff, right? So all other transactions just waits. But you have to be in a read committed isolation level for that to work, right? So it gets a little bit complicated. But I just wanted to explain these two isolation levels, guys. Let me know in the comment section what do you... All right, guys, I just wanted to explain these two isolation levels. Hope you enjoyed this. I'm going to see you on the next one. You guys stay awesome. Goodbye, yo.